Okay, we're on. All right, here we go. All right, so simple notes. Doing a stem and leaf, comparing two sets of data, which has some value to compare two classes. So test scores. What's the 9 represent in the middle? Those in the 90s. So 94, 95, 97. Very simple. And then lo and behold, of course, as I've said all year long, period 5 is the best period. Look at all those grades. Huh? All right. So they obviously had higher scores compared to period 1. Got a little 21 in there, right? Little outlier. 33, I'd call that an outlier too. 48, all right, but still an F. And then a lot of Fs in that first hour. I was telling a story about I had a cat class many years ago, at least 5 or 6. Right, 2 cat classes that right in the middle 70s, like 74, 75 class average. Then a third cat class of a 64%. Now you talk about an outlier class, not just an outlier individual. How's that come? Okay, so yeah, so it can happen. So when I look at this data, is the test valid? Well, heck yeah, it's valid. What's invalid is that 21. How could someone get a 21 sitting in here? Right? That's what I say. I don't know if I'm supposed to analyze the data that way. That's the way I do it. So I thought stolen off the internet from the other teacher, which is fine. If we get in trouble, it's her fault, but I'm using it too. Just some data of temperatures. So go ahead for giggles. Go ahead and do a double stem leaf for this data. Now, to not be confused by a question later, the temperatures listed are the average monthly high temperatures for the month of January. So the month of January in Pittsburgh, they took all 31 high temperatures and then found the average, which still seems high for Pittsburgh, 37, so on and so forth. So take a minute to do a double stem leaf yourself. And then we do have some questions that exercise some vocab from the test or quiz that we had. So what did they do that's different than probably what you did? They flipped it. It's not a big deal. Just to being able to see the data in clusters. Well, that's too bad. Okay. And then some questions like this. So just thought I'd throw this in here to exercise some words. Up at the top, shh. What are 2 observations you can make about the data? Just put something in a complete sentence. Something that you already knew. Phoenix is hotter than Pittsburgh. And then something else about the data that you recognize. Who cares? Just write something. Satisfy. But then definitely, what is the range of the temperatures? And how do you calculate it? Don't write about that, but is there a mode? If so, what is it? 4, data clusters. Write something about that. 2, 3, definitely terms, and then definitely 5. Try to find the median high temperature. Remember, these are all the high temperatures average for the month. What's the median for Pittsburgh? Go ahead and take a minute to try to find those things real fast. We picked on a group. They did get the range right. I'll show you the answer to that for a minute. 48 for Pittsburgh, 40 for Phoenix. Has anyone ever been to San Diego? I love telling this. I said it all day long. Oh, you know what's great about San Diego besides like a lot of stuff? Do you know what the range is between high and lows throughout the year? No. Maybe even less than 20. That's what's great about San Diego because its temperature barely gets in the 90s ever. Probably not hardly ever because a position on the ocean they're at, very refreshing air. The way the ocean is right there, it's pretty temperate. So, the ocean can affect what the wind temperature is. And then barely, in the 60s, it probably even barely ever gets in the 60s. So that's why people love San Diego. The range of temperatures is very small. So you can expect a range less than 40 for sure, probably in the 20s, maybe even less than 20.
You know who doesn't like San Diego?
All right, let's move on. Okay, let's just get okay. All right, now, the next thing. What was the next thing we asked? Was there a mode?
No.
Why? What's mode mean? Most. Every temperature happens what? Once. Okay, so there is no mode for either city. No temperatures are repeated. What was the next thing? 4. Clusters. Yeah, you could just say something about clusters. I don't really care about that. Put what you want. I would grade it on a test if it just is sensical, makes sense. 5, median. What is the median for Pittsburgh? What do we get? I heard someone say 63. Nice. What they have here is I don't technically agree with, because what you're supposed to do with mode is get the middle score. These are an even amount of numbers, so the middle score is 2 numbers is in the middle. The 8th and the 9th number are in the middle of the data, so you have to take the average of those two. 62 and 64 are in the middle, so the median is 63. Okay? All right, then we'll just finish off these notes. Again, I'm just shoving them at you. Really is no purpose otherwise. I mean, it says everything we need to. Remember the whole point of the beginning part of the chapter? Take the same set of data and put them in different pictures to see which one's your favorite, especially if you were going to present this data to somebody. A comparison histogram, we're back to our grades for period 1 and period 5. I guess one thing I don't like about the histogram is you lose the actual grades. Like, you only know that there's 3 grades from 50 to 59, but you don't have the actual data anymore. So it's just grouping students in areas. So you kind of lose the data, specific data anyway. You just know something about the data. So it's same set of grades, and then we could see that these bars are way off compared to the 2 classes. So something's weird going on. What I do ask you as you write this down, if you have any questions, go for it. Make sure you at least have 2 items, a pencil and a pen. So that if I asked you to do a comparison histogram, that we would have 2 different colored bar graphs. Some people have colored pencils. It's awesome. Some people have as... Oh, sorry about that, YouTube. Some people have... Bless you, too. Thank you. Some people have that pen that has multiple colors on it. Nice. Okay. And then back to the last one. Shh. I don't know if you have to really take this down, but then this goes back to that little chart where you have to pick what's appropriate for the data given, what kind of pictorialization. And a line graph would not work at all for grades in a class. So, and definitely for this scenario, when you have time with some, data points, a histogram wouldn't work, or a stem and leaf plot. So it doesn't really tell you what you're trying to analyze with this data. What you're trying to analyze is what's the trend. And obviously this trend is ancient. So let's look at it this way. CDs compared to cassettes. And I just found out they still sell cassettes. Student last hour said he bought a cassette this week. Wild. Okay, don't worry about it. Don't worry about it. But do you think the trend in selling cassettes continued in this manner? Yes or no? Yes, I would say it was almost linear. Shh. Do you think the trend continued for CDs in this order? Yes or no? Does anyone really listen to my questions? Because that's an absolute no. I didn't say cassettes, I said CDs. I meant CDs. Has CDs continued in this increasing trend? No. Go ahead. There's a major blip in the data at some year. I'm not sure when it would be that online music got into play, but they still sell them, but just not near as much, and this would plummet. All right. Then one more thing to say about this. Just again, colors, pen, pencil. Then also note, it might be helpful, and it is a good idea for the dots to use different symbols for the different things compared. And I don't think it's really a big deal after that. This shows the relationship. CDs increased as they got more popular. Cassettes decreased. Now the comparison would be CDs compared to downloaded music. I don't know how you'd make that comparison when a CD has 12 or more songs and usually download one song at a time. So that's true too. You can download an album.